Okay, now first we want to create our client socket. So in here I just say man, because in our file, if you notice, we have the socket.c which we have created. Our socket, it is common in it is the same thing in both the client side and the server side, because first we should create a socket to be able to work with that. Now at the client side, we would want to connect to a program, to another device, to another endpoint, to another network interface card, which would have a specific address, an IPv4 address, and also a port number. So in here, in the client side, we should first be able to connect to the other side. But if we want to connect to the other side, we should have the corresponding address of the destination socket. So in here, we say man, and then we go to the socket and hit enter. If you notice, it talks about that. We actually explained about these things in the previous lecture. I just wanted to show to you the what we should do from now on. So it says that a stream socket must be in a connected state before any data may be sent or received. A connection to another socket is created with a connect. So since we have provided the sock stream for our socket, we need to establish a connection between our socket and the destination socket, the server side, which would be listening at a specific port number. At the client side, if we want to connect to that, we would use the connect call in here. So I press Q and say man connect to see the explanation about the connect. Now it says, first of all, we should include the systypes.h also, and then it says the connect system call connects the socket referred to by the file descriptor sockFD. So in here, it takes 3 arguments. The first argument would be the file descriptor of our socket. I said that when we create a socket, a file descriptor would be returned to us, that we could handle that socket or work with that socket using this file descriptor. So it says that connects the socket referred to by this sockFD, the first argument, to the address specified by ADDR. So when we want to connect, as I said, we should provide the destination address, that what do we want to connect to. We provide the address in the second argument, and the third one would be the size of that address. So how do we create the address? As I explained in the previous lectures, and I just created a simulation that how structs work. We created some just 2 data types, one for as a pointer for the IPv4 and another as a unsigned short. The same thing actually happens in here. sockaddr and sockaddr_in are 2 structures that have been defined in different headers, like type.h or different files in one of these 2 headers in here. We create a pointer, as you see in the second argument, which points to these structures. So whether we say sockaddr or sockaddr_in, it wouldn't have any difference, because when we create a pointer, it actually says that this pointer would point to the how do I say that, to a structure based on the sockaddr. So they are both 2 structures, but how much space is assigned to our pointer is depending on whether we create the sockaddr or sockaddr_in. Or in other words, it doesn't have any difference whether we say sockaddr or sockaddr_in. But as you would see in the rest of this lecture, we would create our struct using the sockaddr_in. But I explained the exact difference, that what these things are. The only thing is that sockaddr, I think it has more elements, and we know that the size of a struct is the addition of the size of all its elements, unlike union, that is the actually the size of the biggest element. Okay, I don't want to confuse you now, but you would get the point when we get to the rest of the lecture. So the first one for the connect would be the socket or the file descriptor. So let me just press Ctrl Shift and T and go to the socket.c in here, and we don't need to print that. So we just say, and if you notice in here, let me see what it would return. So the format of the address is addr determined by the address space of the socket sockfd, and then if the socket of type are sent by default, I just want to know what it returns. So the return value, if the connection or binding succeeds in the client side, you would want to connect to the other side. In the server side, you would want to bind our socket to an address, right? So connect in the client side is equivalent to bind at the server side. It says the 0 would be returned. If it's an error, the -1 would be returned. So it would be an integer. We say int b. Again, I just want you to notice to the content of my variable. That's why I don't want to define meaningful variable. So int b, and then we say b is equal to connect. The first one would be a, which is the socket that we have created, or the file descriptor that the socket system call returns to us to handle it. The second one would be a pointer, and this pointer, as it says in here, would be a pointer pointing to the structure of sockaddr. So you would just want to say struct and then sockaddr, and this is the pointer in here. Now in here we should provide the address that we should create. So in here it would be the address, but we haven't created the address using the sockaddr structure. So what I'm going to do is to just comment this line for now to create the address, and I want to just call the address, for example, C in here, and then the third argument would be the size of the address, which is C. So this would cause the connection of our socket to the server. But before that, we need to create the address. So for creating the address, we need to work with sockaddr and sockaddr in. And as I promised, we always want to go in the deepest level possible. So we go in the bootlin.com that I explained about this website, and we just search for sockaddr_in, and we hit enter. Now if you notice, it says that it has been defined in the in.h, which brings us to including another header in here. So we just say include, I think it would be net inet, and then in.h. I just save it. Again, we go to our browser. It says that at line 236 as a struct, the sockaddr has been defined. So I click on it, and if you notice, the struct sockaddr in has been defined in here. It has some properties, if you might, in here. The first property, it says the kernel SA family T. We want to see what this thing is, because we explained that the first one, for example, in a structure should be a data type. So the SYN family in here, which refers to the address family, should be actually a data type. So I want to click on here to see what this thing is. So I click on the kernel. Actually, let me go back, get the control, and click to open it in another tab. If you notice, it again says that it has been defined in two different files, the sockaddr.h. And if you notice again, the kernel_SA family T is nothing but an alias for the unsigned short. So this is the exact thing that we did in the previous lecture. Again, if I press Ctrl Shift and T and search for the mgh struct in here, you saw how we create a structure in here and also create an alias for the unsigned short. The same thing has happened in here. The _kernel_SA family T is an alias for the unsigned short. So in here, the sockaddr in first says that the SYN family would be a 16-bit unsigned short. The second one is SYN port, which would be referred to the port number. So I want to click on the B16 to see what this thing is. It is probably the same thing. So if you notice, again, it has been defined in several different files. I want to go to this types.h because that's one of the files that we have included in our file. So if we go in here again, let me see BE16. So BE16, it is another kind of data type. If we again click on here, so you see just different aliases have been created, but I think we would go back to a unsigned short at last. So in here it's just taking some time. I think there's some problem with my internet. Okay, again types.h to see where bitwise has been defined. Also I wanted to see the U19. So in here, let me just click on some different files in here. So what I was trying to show you is, again, you see Pol IT is a unsigned bitwise, which bitwise would be again an alias for other kind of data type like unsigned short or long, different things. So in here, if we notice, it says, so what I was searching for, you see different data types, different aliases in here has been defined. One of them is signed, which is actually for or U64 was the one that we were searching for. You see that U64 is an unsigned long, which I think is 64 bits. I'm not sure. So again, if we go in here, go back, we wanted to see about the BE16, which we saw it is an alias for U16. But again, the U16 itself is an alias for other things. So we click on different files and we saw that U16, actually it's in here. I said that unsigned short. Yeah, it's not U64, it's U16, and it is an unsigned short, which would be again 16 bits. So you see, when you see these different things in the different files in socket.h or other files, don't get just confused about them. They are mostly just aliases for different things. So in here, what has been done is that, again, let me go back. So BE64, let me just go to the first one. So we said that the second property in here, SYN port, is actually the type of BE16, which is again an unsigned short. So both of the first two properties are unsigned short integers for SYN family. The first one would be the address family, and the second one would be for the port number. Then we have a struct. The third one is the third element in our structure is another structure itself. This structure is in underscore addr. So we want to see what this structure is. I would just get control and click on it. And if you notice, again, it has been defined in a file. So let me just close other files. Yeah. So this file, the struct in addr has one element, BE32saddr. Actually, I shouldn't have closed them. You saw that BE32, I think it is a of type long, but it is 32 bits. Let me just check it again. So BE, you saw it in here that it says BE32. So BE32 is an alias for U32. If you go to the U32, as the name suggests, it would be a unsigned for U actually. Let me just check it. So this was BE32 and U32. If you notice, U32 is an unsigned int that I think takes 32 bits. So let us just go back. You see, BE32 would be an alias for U32, which it means that it is of the type of unsigned int. So the addr in addr would be with the name of saddr, which is a variable of the type of unsigned int taking 4 bytes. Let me go back to the first one. So our structure, the sockaddr in, which we are pointing to, which we would be create and then pointing to that structure, has three different elements. The first one would be the scene family, that you would see what are the possible answers or values for scene family. Then we would have the scene port, which is again of type unsigned short, and then we have another struct, which that struct has another element, and that element is a unsigned integer with the name of scene addr, which is the internet address and IPv4 address which we should provide for the address. So this structure would be the address that we provide to be able to pass it to the connect system call.